So if you want to create a Mips program, that what it does is it takes a number. Let's work on a hexadecimal number. The length of this number is 8 hexadecimal digits. And now the goal of the program is to tell how many even digits are in this hexadecimal number. Now remember that in hexadecimal we have letters as numbers when we are getting to 10, 11, 12. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now instead of 10 in hexadecimal I will say A, instead of 11 I will say B, instead of 12 I will say C, and now 10 and 12, for example, are even numbers. So A and C are even numbers when I regard them as hexadecimal numbers. So I need to count them as even numbers if they occur in the number. So the goal of the program is to identify those even numbers in the even digits in the hexadecimal number. So again, we have a 8 digits hexadecimal number, and we want to count them. I want that the program will tell me how many even hexadecimal numbers are in this number. So the idea is clear. Now let's try to do it. So let's think about the Mips program. We're starting with the data. So in the data, let's call the number we are going to work on, the 8 digits and hexadecimal number. Let's call it first, and it will be a word length because if you think of 8-digit hexadecimal number, remember that each digit in hexadecimal number is translated to 4 digits in binary, right? For example, a F in hexadecimal is 1111 in binary. So 8-digit hexadecimal number is like 32 digits binary number. So the 8 digits hexadecimal number is in the length of 32 bits, which is a word. Let's consider it a length of a word. So the data will hold this value in, let's call this variable first. I will enter a word length number, which is the 8 digits hexadecimal number. So in first, this variable that is called first, I will enter this hexadecimal number. Now we are going to the main part of the program. Let's put it inside a text area in global main. And what is going to happen is that firstly I'm going to load the hexadecimal number that we are working with. So I will use load word instruction in Mips. So let's load the word to a register. Let's call it S0, for example. So we will load the word first to a register named S0. Now let's create a counter that will be used to count how many digits we are left with. Something's not right. Wait. Okay, so this is okay. What is going to happen is that I will put a counter. We will start this counter that will count how many even numbers, even digits, are in my number. I will start it with 8. Namely, I assume that every digit in the number is even. And now every time I will encounter in the number an odd digit, I will decrease from this counter a value of 1. And now, so let's start the loop, and in the loop I will need to check if what I will do is check every time the least significant digit in the number. Oh, wait, I'm gone. Okay, I will check the least significant digit in the number. What is the least significant? If you think of the number, it's the most right one. And every time I will check this digit if it's even or odd. If it's even, okay, continue. If it's an odd number, an odd digit, I will reduce 1 from our counter, which again starts with the value of 8, and every time we encounter an odd number, I will reduce from this counter a 1. Now, how do I know if the first digit, the least significant digit in my number, is even or odd? And if so, how do I get ahead? How do I progress? So to know if the first digit in my number is even or odd, I will use masking. What I will do, I will call add immediate, and I will take the number, the 8-digit hexadecimal number, and I will do add immediate of this number with 1. Namely, think about it. If you have 8-digit hexadecimal number and you have a 1, just a 1, so it will be in the length of my hexadecimal number, and the rightmost, the least significant bit in this 1 number is 1. In binary, 1 is just 1 0 0 0 0 0 0, right? So this is it. And now when I'm doing add immediate, end, the operation end, it's masking. Yes, what I'm doing here is masking. If I'm doing end of my hexadecimal number and just 1, what I will do is, what I will do is that if you think of it, think about the least significant number in the hexadecimal number. If it's even, so in the rightmost part of the number, there will be only 0, because if you think of a binary number, when it is even and when it is odd, it is even if the rightmost value, the rightmost digit is 0, and it's odd if the rightmost digit is 1. So by doing AND operation on my hexadecimal number and 1, what it will do is it will like going to the least significant number and ask, do you have a 1 in the rightmost part of you, in the rightmost digit, or no? If you have 1, namely you are an odd number, so this 1 will stay. And if you are an even number, namely the rightmost digit is 0, so it won't stay. I mean, if there is a 1, so only the 1 will stay and everything will be 0, because it's end. End with 1 is just everything 0 except for the rightmost digit, and if the rightmost digit is 1, so we have 0 0 0 1, and if the rightmost digit is 0, so just have all of the result are zeros. So we understand from this operation that if the current rightmost digit in the hexadecimal number is odd, I will have 1 from this masking with end, and if it's an even number, so I will have 0 by this masking with the operation end. After I do this operation, I will save the result in a variable. Let's call this variable t1. Now what I will do, t1 will have the value of 0 if the digit we are currently working on is even, and 1 if the digit we are currently working on it will have 1 if it's odd and have 0 if it's even. Okay. Now I will take this result and reduce it from the counter. I will reduce 1 if the current digit is odd, and I will reduce 0 if the current digit is even. Okay, so we understood how on the current number to take the rightmost digit and understand if it's even or odd, and if it's even, don't reduce anything from the counter. If it's odd, reduce 1 from the counter. Now, how do I push this digit away and give place to the next digit to evaluate if the next digit is even or odd? What I will do is just remove it. I will move the number to the right and get away from the current most right digit that we already checked. I will use I forgot how we call it. Set right logic. How do you say this? Let me check. I think it's shift right logic. I forgot. Yes. So shift right logic. I will take the number and shift right logic of 4, because every digit in hexadecimal number is 4 bits in binary. So I will shift right the hexadecimal number by 4 and get away from the digit we already talked about and give place to the new digit, which will now be the new least significant digit or most right digit, whatever you want to call it. Okay, so now we will branch again to this end part. Namely, again, do the masking, check if it's even or odd, and again, if it's even, decrease by 1. If it's odd, decrease by 0, which is nothing. So this will be in a loop, right? So I will do the operation, the instruction, branch if not equal between S0, which is the hexadecimal number that will be 0 when we are finished with it, when we shifted right everything, all the digits, and 0. If my current number, my hexadecimal number, and 0 are not equal, I need to continue. So I'll call it a for loop and do it again and again and again. And masking, checking even or odd. If even, reduce 0. If odd, reduce 1 from the counter. If my hexadecimal, and shift to the right. If I didn't get now a 0 number, so continue, do it again, again. So it will be in a for loop. So we need to do branch if not equal, S0 and 0, and branch if not equal to where, if we are not yet, done if S0 is not 0. So branch again to the start of this loop. And if we are done, namely the hexadecimal number, we shifted all to the right, namely the hexadecimal number became 0. So branch if not equal, no. So we'll continue. So I want to exit the program. So again, we will insert to the variable v0. In order to exit the program, we'll insert the value 10 using a load immediate and exit the program using cscope. So this is the idea. This is the program of how we can use in Mips a program that can check how many even numbers are in a hexadecimal number. The result will be, as you can understand, in our counter that we decrement every time we found an odd number. This is the counter that we called T0. This is the register that we called D0. Thank you very much. This was the idea of how we can use in assembly Mips, how we can write a program to evaluate how many even digits are in an 8-length hexadecimal number. Thank you very much. If there are any mistakes or correction, please tell me. And that's it.